I'm in the meeting. I can run the slides. Is this working? Test, test. Yeah. Ready? Okay, good morning. Welcome everybody to Prague in this wonderful meeting room. This is DINRG, Decentralizing the Internet Infrastructure, research group of the IETF. And this is Li Shazhang. I'm the Kutscher, and glad that you made it to the meeting. Quick usual notes. So we are following the IETF IPR policy. So in short, this means if you talk about any IPR related material or you happen to hear anything, you are supposed to inform us soon. All right, I need to, this is it's a bit low, so. And please take note of the code of conduct that we are operating on. There's an ombuds team that is happy to help you with any issues or concerns. And also consider the code of conduct RFCs and the anti-harassment procedures. And quick reminder, so we are here in the Internet Research Task Force, so we are not setting any standards, so this is purely about research. Eventually, work of these research groups may inform future standards, but so don't expect us to produce any of those. And yeah, so before we start the meeting, we absolutely need a note taker. And we're happy to, well, thank you very much. That's great. So if you, assuming I can figure out the note-taking tool, but I seem to be working. Yeah, that's great. So it's linked from the IETF meeting agenda. And so if people want to help Rod, so adding some things, or he's taking notes online, please do that. That's typically quite useful because sometimes when discussions are a bit hectic, it's difficult to catch everything. Okay, so we have a pretty full agenda today. It's quite exciting, so really looking forward to those talks. Let us know if there's anything else that you want to talk about. So we left some time in the end for discussion, and so let's discuss a bit about future ideas for future work or next steps then. So this is an update. So we last time we talked a little bit. So what we want to produce in this group. So you know, the different IETF groups you know, have different approaches. Some groups who are working more on, say, experimental protocols, they produce experimental RFCs eventually. Since we have a fairly broad charter in this group, so we are typically inviting people from different communities. We're inviting talks on research papers and so on. We felt that it's not so appropriate for us to produce many internet drafts that would eventually lead to maybe informational RSCs and so on. So that's why we discussed a little bit with Colin, IETF chair, and so we think that typically the work that we would be discussing here would be published via, say, other research channels, so academic conferences, journals, and so on. And of course, there's also some other work in the, say, larger IETF community, so some RSCs, people are working on some topics related to centralization. That's, of course, also something we want to discuss here. So that means we don't necessarily plan to publish RSCs anytime soon. So we may want to reconsider that later if we say have some say specific work items that could lead to such material. But for now, we think it's most appropriate to operate in this direction. And to facilitate this a little bit, so we started populating the DINRG wiki that's linked here. And so we opened that up for everyone. So if you want to add some material that you find interesting, noteworthy, and worthwhile discussing, please add to this. If we want to also add, say, new headings or change the structure there a little bit, that's also fine. So please do this responsibly, and yeah, please share your material that you come across, and then we can then discuss how to take this on later, perhaps, and discuss this at future meetings. Are there any questions related to this?
I would just add a bit to what Dirk said. So currently, we sort things into a few categories. For example, Mark's draft, that's I think is under active documents because it may go through further revisions because it has gone through version 3 now. And for published papers, that's, it's published, therefore it's a final version, therefore it's under a different category. But like Dirk said, the wiki is open to everyone to edit. Please feel free to create new categories and put the relevant documentation onto the wiki. As a research group, we depend on everyone's contribution to collect all the relevant material related to centralization or otherwise decentralization to conduct our research.
Okay, so here's just how it looks like, but I guess you can click on the link yourself. And so in terms of topics, so this meeting is largely focused on these two topics, so like measurements of centralization, and then we are discussing few approaches that might be helpful towards decentralization in the, say, broader sense. And so we are currently discussing with some like people from, say, regulation and economics communities like for the next meeting. So that would be probably Brisbane in Australia. So where we would talk more about yeah, economics and also policies that are currently being prepared or put in place in different countries. Of course, your input to that is highly welcome. So if you have additional ideas, please don't hesitate to contact us. And so with that, we would be ready to start the technical program. And I would like to ask Tobias to share his work. Let me bring up your slides. Yeah.
Okay, so welcome everybody. Sadly no timer. So I will be briefly talking about the case of AS59645, which is basically making it ping and doing stupid things. First, a little disclaimer. I know that this is the MPI informatics slide template, but I'm mostly speaking for myself and not on behalf of my employer. And AS59645 is a project of mine and not endorsed by MPI Informatics or in any form affiliated besides me working for the MPI. And I'm reporting personal experiences here for running an AS. I, of course, reflect on them through the lens of a network measurement researcher. But it's this is not endorsed by the MPI. So what is it? Well, first of all, it is an autonomous system, like we know them. I mean, AT&T has one, Deutsche Telekom has one, and apparently I also have one, consisting of systems, servers put into several locations. This is the POP in Düsseldorf, so POP, point of presence, where I have a couple of virtualization servers and a little bit of routers. And topologically speaking, it's more like this. Don't know if this works. Of course, it doesn't. So in the center, you see the location in Amsterdam. Then to the left from your perspective, there's a lot of Düsseldorf with a couple of upstreams and downstreams. And on the right, we have Berlin. In total, it is currently originating 5 IPv4 prefixes and 10 IPv6 prefixes, which accumulates to a total of 7/24s in IPv4 and roughly 1,000,048s in IPv6 because, well, there are 2/29s in there. There are a total of 6 upstreams over several locations and 9 downstreams. So it's actually providing transit as well, and a theoretical maximum bandwidth of 34 gigabits outbound. This accumulates my upstreams, but also to real IXPs, so D6 in Düsseldorf and InterX in Amsterdam, and 3 more virtual toaster IXPs. And the whole thing has been going since 31st of January 2022. And I kind of acknowledge I am somewhat privileged to have some IPv4 around. The reason for that is I applied for it in 2009 when there was still enough. Yeah, but as with all stupid things I tend to do, the standard question is why? So first of all, everyone needs a hobby, and I'm kind of an operator at heart. It might, show a little bit. And my day job as a scientist is, kind of not so operatory. It's more like writing papers, writing grants, handling funds, supervising students, teaching, and not playing with routers. There's also the thing about learning, because you don't learn how to run things on the internet's core if you don't run things on the internet's core. And it happens to be somewhat difficult to run things at the internet's core if you're not working for somebody running things at the internet's core. It's a kind of tautological thing. Then there's, of course, independence. It's my network, my rules. There's no funny spammers sitting in the same IP block, because if there are funny spammers in the same IP block, those funny spammers are gone quite quickly. And if I move somewhere, if I get a wreck in another location, I just take my IP with me. And of course, the thing I always kind of like is giving back to the wider community, which, if you have these resources, it's surprisingly easy to have things that have impact, a positive impact on people. So, learning. Running networks, as I said, was always a thing for me. I always liked that. And if we're all honest, the internet used to be a network of networks with this nice end-to-end principle. And if you want to ruin your mood, you usually have to listen to Jeff Houston, who does measurements on how this is no longer the case and how it basically is like a unidirectional content delivery platform for hypergiants, which, I mean, I kind of, disagree with. I don't think that this is the internet we should be living in. Also, if you get boxes from, for example, Amazon, you have to deal with these funny Net44 things. I heard, and I never used Azure, but I heard they do Net66. No clue why, but apparently they do. And I mean, it's not best practice infrastructure. Again, if it's your network view rules, you can actually make things like they are supposed to do. And sometimes you just want to, quickly spin up something. And with rising IPv4 prices, it's also a lot easier if you just, run your own infrastructure. If you need like a /28 for something, you just use it. Then Independence, and this is a very important point. I tend to have like very strong opinions about this whole centralization, cloudification stuff. And then there's people going to Amazon, and I'm like, but why don't you just, do it yourself? And they are like, well, it's easy for you to say it because you don't have to build it. Like, doing things yourself is really, really hard. So running an AS and actually doing things myself, it kind of puts some butter to my, well, research work of it, well, not being that difficult if you want to. Also, as a researcher, again, this is like this doing independent research thing. It helped me to do some of my research, because for some things you might need control about reverse DNS. You might need specific prefixes, prefix sizes, the ability to announce them somewhere. And if you have to get that through your IT department, it can have really interesting lengthy effects. Again, renting is expensive, goes into independence. I think at the moment an IPv4 prefix goes for around 15,000 again. If you buy it, if you want to rent it, it's usually between $100 and $200 a month. That gets pricey quickly. And the last thing, it is surprisingly difficult to get a network with working reverse DNS via, and not for, IPv6 that is also DNSSEC signed. So great feature. If it's your network, you handle the delegations, you make sure there's DS records, things work. Yeah, then the giving back thing, and I like to ruin people's mood in the morning. I don't know if you heard about my 13 propositions on an internet for a burning world. Base summary is like shit's on fire, yo. And what I really fear is that we are living in a world that is burning to the ground. Well, it's being burned by us. And we have this progressing centralization, which leads to a capability loss, to people being less and less able to not only maintain the infrastructure we rely on, but also rebuild it and keep maintaining it when this whole support infrastructure around it, Docker Hub, is just gone. Like, we are losing end-to-end understanding of what makes our world tick. And that is bad if the world keeps working. That's disastrous if the world burns down. So by giving back, by enabling people to also do things at the internet score, to get their own ASN, to see how you announce stuff, I'm kind of investing in people knowing how to run stuff. And I hope that at some point that will help us. And being an LIR, so I'm like a local internet registry, which is a really nice feature, and we'll briefly touch on that a slide later. I can also sponsor things for people who want to learn, for example, students. I can also run nice infrastructure, which helps all of us to do network measurements. Like, there's funny sensors of a diverse set of projects. There's a RIPE Atlas anchor, which again also gives me the benefit of getting a lot of RIPE Atlas credits, which then can be used for further research. There's an LNOG ring node, and I can provide a lot of services. Like, there's measurement.network. I mean, I had to talk about that at ANRW at 117. My funny Back to the Future, who is email security scans.org, v6 only resolver thingy. There's the Engel system, which is a system to organize shifts of volunteers during a large event, kind of known from the CCC events at the end of the year. And something that happened during the hackathon, there's also now like a IPv6 only, like only NetV64 for outbound public resolver to AO6 D1C7.
Try again.
Then there's, of course, the thing about doing stupid things. So I have this nice blog, doing-stupid-things.as59645. I can also, if I run my own network, I can also do things that are somewhat stupid. Is there, by the way, a clock somewhere?
Yes, if you, so finish in 5 minutes would be great.
Okay, that would have been good to know. Sometimes you want to do stupid things like domain front commonly censored news websites. You want to maybe do some like funny censorship evasion. You want to tunnel real IP addresses, including legacy, to your home. You might want to run Tor stuff, and you might want to try out new things which are for big networks, ASPA, for example, and I haven't played with ASPA yet, but that are not yet stable enough to be tried out by those big networks, because honestly, it's kind of sad for me if AS59645 goes offline, but nobody really dies. It's a little bit different for DTAC. I can also use it to debug stupid things. So it was a fun thing where an NGO had an issue where they felt a bit rate limited by a very set AS3320 Deutsche Telekom, which could be easily traced to an MTU issue. And there's a lot more debugging you can do when you can actually control in and outbound to the DFZ, because basically PCAP didn't happen, and then you can get those PCAPs from where it hasn't been inflicted on. This was ultimately helping slaying a 16-year-old QAMO bug in the RTL8139. Who here still knows the RTL8139? Okay, I see Jeff shaking his head, but that is probably the shaking of head like, I worked really hard on not remembering that nick. So it's very infamous for bad driver support, and as I said, there's a fun blog article about this. So if you want to get those resources in the right region, natural persons like me can hold resources and become members. So it's IANA, IR, so in this case RIPE, and then LIR, which includes me. And in the RIPE region, there's different types of resources. So you have provider independent resources, which are direct assignments from the RIPE NCC to end users, natural persons or companies. You have PA, which are allocations to LIRs, to members of the RIPE NCC, of RIPE, from which they can make assignments to end users. And AS numbers are always kind of direct assignments, and they come in 16 and 32 bits. If you become an LIR, it's relatively simple. You apply with the RIPE NCC, send a couple of documents, pay a sign-up fee of 1,000 euros plus tax, and your first year's membership fee, annually reoccurring, 1,550. And then you can request your initial allocation of a 32 to 29, an ASN, and you can queue on the IPv4 or waiting list to maybe someone eventually get a prefix. If you just want to get PI, you find a sponsoring LIR, like me. You sign a LIR agreement with them, you ask them to apply for 48 and an ASN. The LIR is charged 50 euros plus tax per year for the PI prefix, and currently ASNs are free, but the RIPE has some opinions about that. And the LIR will then usually charge you a bit more because they also have to, cover their costs. Tends to be around 100 euro per year and around 50 euro per year for an ASN. You have to somehow get IPv4 at least /24 to be able to also announce it. You can buy it, it's 15,000. You can rent it, it's around about 100 plus. And then there's also a couple of things you could do, but don't even think about it. Then you have to get connected. So there's a proper way, which means you get co-location in a proper co-location facility, and that's usually at least 200 bucks a month. You put at least one router, a switch, and some servers into that rack. You get cross connects to IXs and potential upstreams, and those are usually like 40 to 100 bucks per pop. Then you get PKI and IRR data in order for your prefixes. You agree on pricing with the IXs and upstreams, set up your sessions, get announced, make it ping. Of course, in the spirit of stupid things, there's also the YOLO call away. So you get any device that can run a routing daemon, think Raspberry Pi. You get one of those free tunnel upstreams from any of the fun upstream providers like freetransit.ch. HE stopped doing this, but there's a couple more. You get RPKI and IR data in order. You set up sessions, get announced, and make it ping. There's a teeny weeny little point about this not actually being a good thing, because in the end, if you're doing this, you are playing with sharp knives, right? And you can cook with sharp knives, but you can also really cut yourself. And there are basically two types of BGP operators. There are those who caused an international incident and those who are lying. It's the same with OSPF. With OSPF, you can break a network in ways you don't understand. With BGP, you can break everyone's network in ways no one understands. And there's more than just costs. It's not like a Raspberry Pi you can pack away, leave in a box and just get it out when you're on holidays again. It's more like a pet. It's a responsibility. You have to keep maintaining it. You have to keep being there for it. And funny YOLO colo setups, just for the sake of it, don't really make the world a better place. There's routing table growth, there's the issue of getting the NTU on the internet below 1,500, which shouldn't be the case, and there's like a myriad of lists which really make operators who do this for a job not really like personal ASNs. There's, if you want to do a little bit more YOLO and less colo, DN42. It's a little bit like the internet. It's a fun small-scale internet with all shortcomings of the real one. They have IPv4 exhaustion and 2 large layer equations. They are running out of 16-bit ASNs. They have a slow introduction of IPv6 despite a pressing need. They have inconsistent databases and a slow adoption of RPKI. So it's essentially like the real thing. But you make a few orders of magnitude people less angry at you when you do something stupid. Conclusion, is it fun? Definitely. Should you do it? Maybe, maybe not. I'm kind of a doctor, well, of engineering, not a cop, so you do you. Is it useful? Well, in a burning world moving towards full-scale societal collapse while losing people with a full end-to-end understanding of its most important technology stacks due to the increasing complexity and introduction of multiple layers of abstraction, driven by the practical needs of large businesses, cloud companies, and market incumbents, further reinforcing the role of people as users and consumers of content provided via centralizing internet. Well, maybe it is kind of useful. So, getting to the end of this, do something good for yourself. Start each day with an apple. Make an evening jog a thing. Start decentralizing the internet 1 AS at a time. Thank you.
Thank you, Tobias. Okay, good start for a Monday morning. Are there any questions? By the way, make sure you scan the QR code so we get a bigger room next time.
Hi, Tobias. This is Corinne Kath. So nice to see you present in person from Delft University. I'm going to ask you a question that I've asked you at different times that you've given some presentations about your work. And that is this question of, you look at the cloudification and you present like one way forward by having this technical intervention by saying like we should all run our own ASs, which is, I think, an interesting part towards it, but does it address sort of the business and the economic power that is there?
Okay, first things first, this is all a social problem and there's no technical solution for a social problem. So I'm also not proposing a technical intervention. It is not about everyone having to run their own AS. It is about having enough capabilities within society that there are enough people to run small scale ASs to take care of their community if we completely lose those hypergiants. Because as it is with stars, hypergiants at some point will go bust. We lost, how was it called, MySpace? For like the older people in the room, it's like Facebook, only older and with funny sounds. And that is the thing. We have to preserve sufficient capability to build and rebuild infrastructure in case of a loss of the supporting infrastructures we are currently relying on, which are mostly controlled by these big companies.
Thank you. That's a helpful clarification.
Okay, thank you.
I think nobody else.
Right.
So ask your friends to scan the QR code too.
Yeah, thanks again, Tobias. And so the next talk is going to be remote from Michael Kroll. And let me bring up his slides first. And I'll give you control. Just a second.
Can you guys hear me okay?
Yeah, sounds good.
Perfect. How do I control the slides?
Yeah, just a second, I get the control.
Oh, okay.
So in the new Mitaco tool, you are moving up, and so now I can give control. Okay. So it should work now. Michael, you have the floor.
It does. Yes, thank you. Right, so I'll present our paper, which is on investigating IPFS, which is interplanetary file system. This is a joint work with Leo, Maciek. Sorry, my voice is leading me. Leo, Maciek, Honor, Navin, George, and Björn. Okay, arrow keys works as well. So I'm going to quickly talk about IPFS in general, because the kind of the measurements are important. for the measurements, it's important to understand how it works. This is currently the largest peer-to-peer data storage and retrieval network. It's used for traditional hosting, NFTs, blockchain reference data, dApps, and so on. So this is kind of the storage technology for the Web3, but not only. People host their websites and stuff like this on IPFS now. So it's kind of like torrents, but at the same time, with torrents, usually you want to set up a download of your movie and then you wait. Here is for probably more that you will ask a website and you wait for it actively to appear. It has a pretty growing usage. We've seen tens of downloads requests per day. There's certainly many more. And the network is around 30,000 nodes at any given time. Now, I'm going to briefly explain how it works. IPFS is this kind of traditional peer-to-peer system, so anyone can host some data. Now, if you want this data, you have to send a request. The data flows back, and then you have it. And the good thing is that once you have it, you, by default, also start hosting it. So it gives you this really nice auto-scaling feature where if a file becomes popular, the more people download it, the more people also host it. The problem is with the traditional naming scheme as we see in the internet, such as youtube.com/video.mp4. We have this location part, and this makes content migration very difficult because now if you want to move your video from YouTube to Vimeo, well, then the whole name changes. This would be obviously very bad for IPFS because we want to migrate content between peers all the time. So that's why IPFS using a location-independent naming. Basically, if you want the name of a file, you just hash it using a cryptographic hash function, and the digest of this file becomes the identifier of the content. This is good for the application because if there are two the same files, they will have the same name. And also, once you download the file, you can right away hash it and then check the integrity of the file. Now, the problem with this is that if you receive the identifier of a file you want to download it, now you don't know where to download it from because, well, the name doesn't have the location. So to work correctly, IPFS needs some kind of name resolution, which will map the content identifier to a list of providers from whom you can download the file. And IPFS has two protocols for doing that. One is BitSwap, which is a very simple protocol. You just connect to random peers in the peer-to-peer network. And when you want to download the file, you just ask them where they do have this file. If they do, they will provide it to you. If they don't, well, they will not. This is pretty fast because, all the requests are being sent in parallel. It's a bit expensive because if you want to have a decent chance of getting the file, you need to send probably a lot of requests. And you're not guaranteed to find the file because you're contacting only a subset of the peers. So it usually works only for popular files, and it doesn't for less popular ones. And that's why IPFS also has a second protocol based on the distributed hash tables. This is built using Kademlia. And basically, every single server in the network is responsible for storing some mappings between the content identifiers and the list of providers. Now, if you want to advertise yourself as a provider, you just do a DHT put operation. If you want to get or resolve a file, you just do a DHT get. Now it's slightly slower with the BitSwap because now you have the DHT routing that you have to go through. However, it's still efficient with the network size, and you're guaranteed to find the content. So that's the core protocol. On top of that, IPFS built some additional things to make life of the users easier. First of all, we see quite a lot of a lot of peers behind NAT. This is obviously problematic when you're hosting a content because people cannot connect to you. And that's why IPFS allows relays. So basically, when you advertise yourself, you can say, hey, this is my ID, but you want to talk to me, please talk to this relay. And the relay will be able to relay the traffic. So it's nice because it allows NAT peers to communicate with the network. And on top of that, IPFS also implement HTTP gateways. So by default, every single node in the network exposes an API where you can send HTTP GET requests specifying the content identifier, and the node is supposed to fetch it from the IPFS network and give it back to you using HTTP as well. And this is a nice feature because now you can use any major browser. You just type the URL of a browser of a gateway / you put the content identifier, and it kind of fly to you using HTTP. You don't need to install anything, any plugins, nothing. It just works using pure HTTP. Now the Brave browsers also has extended this support where you can just like put the content identifiers in the browser, and the Brave browser will understand that this is an IPFS address and will fetch it for you automatically. Right. So for the measurements methodology, we're looking at two aspects. We wanted to see, well, this is kind of the main decentralized storage. So we wanted to see how decentralized is it. And we're looking, first of all, at the traffic distribution. We wanted to see whether we have some heavy hitters or maybe the traffic is distributed equally. And also we wanted to look at the reliance on the cloud infrastructure. This is important, especially for all this like Web3 and blockchain-based ecosystem, because they usually do not want to rely on the cloud. And for that, we built quite a lot of software. We wanted to have kind of a holistic view of the network. So first of all, we have a network crawler. Then we have a DHT and bitswap traffic sniffers, which allows us to get all the content advertisements and download requests. We have a gateway detector. And this is because the HTTP gateways sometimes have different IPs on the HTTP side and different on the IPFS side. So this is the tool just to correlate them. And then finally, we did some also DNS measurements, because now we can also use DNS to reference IPFS content. And then ENS crawler. ENS is Ethereum name system. This is this kind of blockchain equivalent of the DNS, if you wish. Right. So for the results, at the beginning, we looked at the network itself. And we found out that 85% of the IPs are actually hosted in the cloud. This is a pretty scary result, and also it was a bit surprising because 1 year before there was a SIGCOMM paper presented, and it found out that there's only 3% of the nodes in the cloud. So going from 3% to more than 85% in a year was a bit surprising. And actually, it was a difference in the methodology. So for us, we were taking a snapshots of the network. We're taking all the IP addresses and we're classifying them as cloud or non-cloud, and then we're aggregating those results across multiple scans. For the SIGCOMM paper, they were scanning continuously the network. They were gathering all the IP addresses, and at the end, they did the classification between all the IPs they see. So when we took our data set but applied their methodology, we indeed seen very different results, because now the non-cloud ratio jumped to around 60%. And this is because the non-cloud nodes actually rotate their IPs very frequently. So that's why if you aggregate your results across multiple scans, the same node will be represented by multiple IPs, and thus will be counted multiple times as well. So here we have a graph showing on top of that, you have the blue line, which is our methodology. The more scan you aggregate, well, it doesn't change much because the network is pretty stable. However, with this methodology from the SIGCOMM paper, the more scans you aggregate, the more overcounting of the non-cloud nodes you have, and thus, well, eventually you'll get down indeed to this like 3%. And then we looked also at the network, at the cloud providers for the cloud nodes. And again, we see that the first three operators, and this is Trupa, Vultr, and Contabo, then they control basically more than 50% of the network, which is again a bit scary. At the same time, you can see that for this SIGCOMM paper, so different methodology, the picture is quite different. So just to highlight the small differences in kind of counting or evaluating how something, how decentralized something is, can paint a very different picture. Then we look at the traffic. So we were using DHT and bitswap sniffers, and also simplified Pareto charts. So on the x-axis here, you have the percentage of the IPs, and on the y-axis, you have the percentage of the traffic that those IPs are responsible for. So basically, this data point means that there's like 5% of the IP addresses that are responsible for more or less 95% of the traffic. So the traffic is highly centralized in the DHT. In the bitswap, it's slightly better, but it's still pretty centralized. At the same time, we also looked at what percentage of this traffic comes from the cloud nodes. And for the DHT, we see around 90% is coming from the cloud. And also all the heavy hitters here on the left-hand side, they come from the cloud. From bitswap, it's slightly better because it's only 40-something%. And then, yeah, I'll tell you why in the next slide. So now for the old cloud-based nodes, we did reverse DNS just to try to guess what they are doing. And for most of them, we don't know because we just see that it points to some Amazon AWS. So we see that even though Amazon AWS there are not a lot of nodes in our crawls at the beginning, they're actually very active in the network. For the advertisement, you see, we have seen a lot of kind of this Web3 storage, NFT storage, and so on. So those are kind of blockchain ecosystem related services that host a lot of content such as NFTs, and they have to periodically advertise them. That's why we see a lot of traffic coming from them. And we don't see that for the download traffic. And that's why also in the previous slide, you could see that for the BitSwap, we have less cloud traffic in the BitSwap traffic because BitSwap is download only. So basically, the advertisement or the hosting of the content is much more centralized in terms of cloud reliance than the download traffic. And then we also looked at the content providers, so nodes hosting content. We found out that 36% are non-cloud nodes but behind the NAT, 46% are the cloud nodes, and 18% are non-cloud nodes but with a public IP address. Then if we zoom to the NATed peers, I told you before that they rely on some relays to be able to communicate with the network, and actually 80% of them used a relay hosted in the cloud. So even though they're not in the cloud, they rely on the cloud to communicate with the rest of the network. And then for the content itself, we found out that only 5% of the content is hosted uniquely by non-cloud nodes. The vast majority is hosted by a mix of cloud and non-cloud nodes. And finally, we have around 25% being hosted uniquely by the cloud. And then finally, for the gateways, as I told you before, there are like different IPs on the HTTP side and different IPs on the IPFS side. And but in both cases, you can see that the Cloudflare dominates the market. They operate the largest gateway infrastructure. It's actually not surprising because Cloudflare invests quite heavily in IPFS. They added quite a lot of support and they kind of integrated with their platform. But again, you can see that the non-cloud platforms, non-cloud gateways are almost non-existent. There's a very small portion of this kind of gateways. This might be kind of understandable because it requires handling quite a lot of traffic if you run the public gateway. So maybe that's why people decide to that it's too difficult to run in at home. And then finally, we look at the Ethereum name system. So Ethereum name system is this kind of DNS, but hosted on the blockchain. It referenced sometimes some IPFS data. So we looked at this data and we wanted to check who hosts this data. And again, even though it's kind of referenced by the blockchain, you see that the majority of that is hosted by the cloud. Only 18% of the content is hosted on non-cloud nodes, and the rest is either kind of regular cloud providers such as Amazon, but also DigitalOcean, which are kind of more specialized in hosting this kind of blockchain-based data. Right, so for the summary, we found that almost 80% of the DHT servers are hosted in the cloud. The top 3 cloud providers host the majority of the network. The traffic is highly centralized because the top 5% of the nodes are responsible for up to 95% of the traffic. Nearly 95% of the content is provided by at least one cloud-based nodes. However, 25% is provided only by cloud nodes. And for the entry points, such as public HTTP gateways, they're also dominated by a few large players, such as Cloudflare. So just a few takeaways. If you look at the design of the IPFS, it looks like a robust base for the decentralized web. It's pretty standard in terms, it looks kind of like a mix between the DHTs and the BitTorrent. However, it seems it's very difficult to achieve decentralization, performance, and security at the same time. We have another paper coming, we'll publish it on the NDSS next year, where we show an attack where it can basically delete any file from IPFS using a single laptop because there was a vulnerability in the DHT. And since then, we patched it. However, the problem is that, well, now you get a small performance hit. And that's usually the pay that you have to pay in a decentralized system. And especially the performance is difficult at the content resolution layer because now the DHT query took around 1 to 2 seconds, which is pretty slow. Protocol Labs tried to build kind of Hydra boosters, which are kind of DHT supernodes. That didn't work out that well because the improvement was not really good. And now they're actually introducing centralized indexers. And now the resolution time went down from seconds to milliseconds. But now we have all those problems with privacy preservation and censorship and so on. So obviously, maybe censorship is less of a problem because you still have the DHT as a fallback, but the privacy concerns are there. NAT is still a problem. There are quite a lot of nodes behind NAT, and there are some protocols to be able to connect to them, but they're still a bit slow. In general, there are like non-cloud nodes that come and go. So the vision where you kind of host your website on your laptop is not very realistic in the sense because if you shut down your laptop, your website also disappears. We see a lot of this kind of content that is hosted only by a single node, and it just like comes up and down periodically. And I think what is commendable is there is a huge progress on the practicality and the ease of use. I think it's amazing that now you can kind of use a browser and then just like click on the link and the content is going from a decentralized network and you don't even know that. But definitely there is like more work needed in this direction. And I think this is it from me. Thank you.
Okay, thank you, Michael. So while we are asking questions, please make sure you use the online tool for queuing, because otherwise it's hard for the note takers to get your names. But okay. Go ahead anyway.
Okay. I'm Michal. Thank you so much. Great talk. Just 2 comments. So we wrote the SICOM paper you were referring to. And so I think IPFS is kind of a moving target. That's sort of what I wanted to say. And you mentioned it's like, so the paper was published 1 year before, but actually the data is from even 1 year earlier. So it's 2 years old. And since then the network has tripled in size. So I'm not surprised that the cloud reliance has increased over time. Nevertheless, I think your methodology in counting and aggregation of numbers is more sound. So this is something I wanted to say. But I wanted to ask, did you include relay addresses into your cloud nodes as well? Because they could artificially inflate the numbers of cloud reliance. So this one question. And the second one would be, have you used your aggregation for our data sets as well? Just to see how the numbers would compare with your aggregation? Because we published our data sets.
Right. So starting with the second one, no, we haven't checked your data set with our methodology. We did the reverse thing, but yeah, this will be actually very interesting to see. We have all the scripts. It's probably adapting the data. So yeah, I'd be happy to actually have a look at that. And then for the relays, I'm trying to think. So you mean for the DHT data, right? Or
right. Yeah. So nodes are announcing relay addresses, which are most likely also like, so these relays are hosted on cloud nodes, but still they are behind NATs or non-cloud nodes, basically.
Right. So I think for the traffic, we use the actually advertising nodes. So those will be non-relay nodes, if I understand, if I remember correctly, because I think in the Hydra booster logs, yeah, we've seen, yeah, like they will be in the advertisement. We'll see the relay, but the message will be actually coming from the node that is advertising. So we should count the nodes and not the relays in this case.
Right. Okay. And one last thing. So you said the Hydras didn't have like such a huge performance impact. I think this is true for the beginning of the year or end of last year, but when they were introduced, as far as I know, or actually I think they had like quite a significant performance improvement, because back then nodes were behind NATs and still participating in the DHT. But yeah, just a comment. I think this is, yeah.
Okay, I mean, just to be fair, I don't know. Actually, it's difficult for me to measure the performance boost of the Hydra boosters. I just know that there were some discontinued, so maybe it was more about the ratio cost to the performance boost that that was assessed, but probably better actually. So.
All good. Okay, thank you.
Okay, next in line would be Jeff.
Jeff Houston. Look, I can't help but muse about this and think about what you're trying to do, and why I think your direction is kind of anti-gravity. The problem about all of this is that we actually engineer our networks and their infrastructure based on the majority use profile. Our networks are asymmetric for a reason. And the reason is that most end clients suck like crazy and push nothing. So almost from the word go, download speeds were a whole lot higher than upload speeds because this isn't telephony. And so we build networks that fan stuff out. And that's what we're good at and what we're cheap at. Once you try and create content at the edge and suck it back in, you really are pushing hard against where the engineering and the capital investment actually went. And this is kind of the first problem here, that these kinds of models, the cloud was an obvious answer because it's in the middle, not at the edge. And if you try and create in software edge-based systems, you're pushing against where the engineering is. The second part is that we coped with address exhaustion and address scarcity for this by the same reason. Clients don't have addresses. And they really don't. They're just clients. It doesn't matter what address they have. Because you're only sucking and never pushing, I never have to initiate a connection with a client, so I'm reliant on your relays. Now, there's a real problem with reliance on relays, and a lot of it comes right here in the IETF. Because when we talked about NAT-based solutions, there was almost a religious fervor in the IETF that we were never, ever going to standardize NAT behavior because they were satanic inventions and therefore didn't deserve standardization. The result was that every single engineer assigned to build a NAT had no standard to work from. They're all different. Every last one. Even the same model is different from each other in different years of manufacture. NATs are a disaster, and NAT transition is a disaster. And so when you're talking about a decentralized system that relies on edges, where clients don't have addresses, and Tobias, if he's still here, has addresses, lucky him. Without them, life would be crap. And we all know this. The NATs are just horrible. And so to some extent, what you're doing is academically interesting and curious and wonderful. But in terms of templates for where the industry goes, as I said, I really think you're in the anti-gravity area. We don't see the money in this. We don't build according to this template. Where we make things cheap and why we make things cheap is actually in massive centralization. And this is kind of the conundrum in this entire research group, that the real issues here are capital and economics. The technology you can bend in many ways, but we're just not building these kinds of networks. So it's a curious thing, and I love it. You know, it's just sort of Tor all over again and distributed hash tables, etc. But unfortunately, I don't think it's got a big, a bright and shiny future in the commercial world. Thank you.
So I think it was not a question. I just wanted to clarify. I'm not from IPFS. I'm a researcher. I just measure IPFS. I mean, to be honest, it's difficult for me to comment on the economics because I don't know nothing about it. For me, it was encouraging to see, for instance, entities such as Cloudflare kind of going into the space, because for me, this was a sign that, well, they see the money in it. I don't know how, but if they do, I hope they, like it can. It still works, but maybe you're right. I'm not probably the good person to comment on that.
Okay, I think I'm the next one in line. First, I want to say thank you, Jeff, for your great comments. I agree, except one. You were saying that they not well, perhaps he said he's not IPFS. You say they were doing academic research, and I'm in academia. I wasn't sure, because I look at the results, look at the takeaway still on the slides. It says that IPFS is a robust base for the decentralized web. Right? Everyone read that. But the slides right before it, the summary of the results give you very different fact. It essentially says, 80% of DHT servers are in the cloud. Top 3 servers serves more than half of the traffic. And the nearly 95% of the contents provided by at least one cloud-based nodes, how those numbers support the conclusion about IPFS as a robust base for decentralized web. As academia, I mean, I notice the numbers and just notice that inconsistency between the numbers and the resulting statement.
I think so. My perspective when I wrote the takeaways from the engineering perspective, I think that IPFS is coming from a kind of long line of research about the decentralized or peer-to-peer systems, and I don't see any kind of major flaw or something that we should do something like this and then it will work better. I think then that maybe it's like mostly the economic or societal issues. I mean, as I said, it's probably unrealistic to think that people just like use their laptops to host content and will be fully peer-to-peer. And maybe that's not a model that we should go towards, because as we see, like people use it differently. I mean, it's just much easier and probably cheaper to just like rent some hosting space at Amazon rather than host something yourself, especially for the majority of the people. But yeah, so I just want to say that for me, I don't see this the problem with stating that IPFS is a robust base for the centralized web, because I think technically it is. But then the other point is, how is it actually used by the players in the network? And yeah, we see that it's actually used quite a lot with the cloud providers. Maybe we could do something on the design level. I don't see that single thing, but maybe also it's like we cannot solve the societal problems, as the previous speaker said, with engineering.
I think we have to move on. So we have two more comments, two more questions. One from Waldemar. Are you? Yeah.
So I don't really have a question, I have a comment. So I'm here a little bit by accident, but what got my attention is the item NAT is still a problem. So as far as I'm concerned, NAT is not a problem at all, because I'm aware of technology that is presented in the int area, which I mean, I don't want to advertise it right now, but what I'm saying, it does exist. So I'm probably going to respond to this group to bring attention to it. What that technology does essentially traverses NAT, it traverses IPv4, IPv6 also. So that issue, as far as I'm concerned, is just gone. And I don't think there would be any relays anymore if that technology gets developed somewhat. And it also kind of makes me think maybe I should get involved in this research group. I don't know. So I'm just going to try to see how this plays, whether it's useful at all. Thank you.
So just for this NAT, I just want to say that like IPFS now also is like having this protocol, like the hole punching protocol, where the connection establishment is with a relay, but then the data transfer is actually peer-to-peer. But actually, I'd be also very interested to see the solutions you mentioned, because yeah, that's not something that is interesting, potentially beneficial for the network as well.
Yeah, so Waldemar, it would be great if you could follow up on this on the mail list. So in general, we wanted to expose IPFS more to this community. And I'm sure there are many more questions, and it would be great if you could discuss this more on the list.
Yeah, I will definitely follow up. I believe the technology is called IPREF, IP addressing with references. Thank you.
Okay, thanks. So we have Christian Hüdemer in the queue.
Yeah, I would like to make a comment on this business of having DHT nodes in the cloud. And I think that is not actually a failure. It's more like a natural reaction to what Jeff was observing. Is that, yeah, I mean, if I am in my home, I could run a server from my home, but it's pretty hard. It's much easier to say that I will have a point of presence in the cloud, and I would have some kind of hybrid system in which the important data is somehow served from my home, but relayed through the cloud, or maybe the cloud is used just for the connection. And I think that evolving the architecture of things like IPFS to be this kind of hybrid between point of contacts in the cloud and a data server in the homes of the publisher might be an interesting future architecture. And we should more embrace that and say, well, yeah, get rid of it. No, it's more about balancing it.
I think this is a fair point, especially I work quite a lot on distributed systems and blockchains, and I think that's also what we see a shift from, everyone should run a blockchain on their laptop to, well, maybe let's give to the cloud what the cloud does best, and then we can maybe do some, let's say maybe it's just oversight procedures to have some performance, like security guarantees, and then this kind of model can be much more efficient.
You have. Yes, you have to look at the failure mode of the cloud. The failure mode of the cloud is that you're going to be some censorship thing or something like that. But if you start from the failure mode of the cloud, then you can investigate what kind of decentralization you want. Which function do you want to put in external nodes, which are maybe behind NATs and firewalls, and which function you want to put in the clouds. Like having real-time relay of encrypted data in the cloud, that's not going to give too much power to the cloud managers. That's things like that should be evaluated, I think.
Yeah, that's a fair comment. That might be the way to go.
Okay.
But it's great. Thank you.
Yeah. Thanks for this discussion. We have to move on. Yeah, let's follow up on the mailing list. I think there are many more questions that people would like to ask, and let's do that. And so next, we are going to have Martin Kleppmann also joining remotely. Let me just bring up his slides quickly. And he's going to talk about local first software.
Hello, everyone. Sorry, how do I control the slides?
Yeah, just a second. You can use your cursor keys now.
Very good, thank you. Okay, well, I'm really happy to have been invited to this group, and I think we have a lot of like-minded people here, which is wonderful. I'd like to talk a little bit about the research we've been doing over the last few years on something that we call local first software. So the context for this is collaboration software, so the types of apps where users can edit some sort of file, typically collaboratively with some colleagues, and have several people editing it at the same time. So you know this from Google Docs, or MS Office has a cloud version, Overleaf for LaTeX documents, Figma for graphics, and so on. There's a huge class of applications that have this sort of real-time collaboration aspect. And of course, the way these apps are built currently is as cloud software, where you've got the primary data storage for the app living in the cloud. Users can access this through maybe a web browser or through some client apps from their local devices. But really, the storage of the data here is in the cloud. And if the cloud is not accessible for whatever reason, be it that the cloud provider has locked you out or something mundane like just you don't have an internet connection right now, then, well, you can't access your data. This is particularly problematic in the case where cloud providers might just close people's accounts. For example, because some automated system thinks that somebody has violated the terms of service and then just closes somebody's accounts, really without any option of recourse. And you keep getting stories from this. But I think I'm preaching to the choir here. So I think everyone's aware of these kinds of problems, and that actually rather large numbers of accounts actually get closed every year, of which only a small fraction get restored again. So this seems kind of dangerous if we're at the mercy of somebody losing potentially huge amounts of work that they've put into, say, the documents that they've written on Google Docs at the whim of a cloud provider. And moreover, I feel there's a sort of, as a principled objection here, we can still read some of these texts from 5,000 years ago that have been written on clay tablets, whereas will we still be able to, in 100 years even, read the documents that people are writing in Google Docs today? I personally don't have great optimism that we will still be able to do this, because who knows what the state of Google Docs will be in 100 years' time, but I suspect it will have probably been replaced with something else, whatever that something else might be. So that have been sort of one set of objections to the current state of cloud software. There's also another objection to the way we currently build cloud software, which is more to do with the effort that the developers of that software have to put in. Because actually, developing cloud software is incredibly complex. It started out in the previous decades being not too bad, where you would essentially have a server that sends some HTML to the client, which is a web browser. The web browser would render that HTML, and then if you want to have some input, the web browser sends a form back to the server. Simple enough, but of course now in the meantime, people have decided that that's not interactive enough. And the modern way how all of these highly interactive, real-time collaborative web apps are built is actually there's a huge client-side JavaScript app that does all of the rendering. It talks to the server via some API, typically like maybe a REST API over HTTP. The server just sends some JSON to the client. Now, if you think about what's actually happening here, there's a huge pile of layers of technology that are stacked upon each other. So starting from the client end, in the web browser, if the app wants to render something, the app probably has some state in some variables in JavaScript, which it can render, for example, using React or some other sort of web UI framework. And any user input, like the click events from the mouse, the keyboard events, and so on, they go into the JavaScript application and update that JavaScript application state. But now if the application wants to persist anything, well, the only persistence is on the server, so it's got to talk to a REST API. So it's got to convert this state from the in-memory state of the JavaScript application into RPC requests, and the responses have to come back from this API and be turned back into application state. On the server side now, well, this API has to be implemented somehow. And so typically the way it would be implemented is that there's some sort of layer of model objects which encapsulate the business logic on the server side. So any HTTP request on the server gets converted into some sort of updates to these models, and then any response takes the models and sends them back out to the clients. These models now, they have to be persisted somewhere, and so they will typically go in a database, maybe using an object relational mapping framework to turn these in-memory objects into SQL. And then the database itself, well, that has some way of then encoding its data in bytes and writing it persistent storage and replicating it and sending it over the network and so on. And if you think about it, this is just madness. There's so many layers of data conversion happening here, and huge amount of application code has to be written just to convert data from one representation into another. So I feel like the current state of cloud software is very much a local optimum. If you think about this, if you were designing an app development platform from scratch today, you would surely not have 6 different representations of the same state and have lots of application code that has to convert between all of these. So what we've seen is a bunch of problems with the way cloud software currently works. It certainly has some great things, the real-time collaboration, the fact that you can access it from any device, that's all great stuff, and we don't want to lose that. But we do have this very precarious situation where the cloud provider controls all the data. Also, the software just doesn't work offline very well. And essentially, the ownership of the data is taken away from the users. We could contrast this with the old-fashioned software that we had before the internet was big. You would have Microsoft Word running on your own computer, storing the files on your own computer, which gave users a huge amount more agency over their files and over what they did with it. But of course, now that you have the downside that you don't have real-time collaboration. And so you have to either send files by email or use a version control system like Git or something like that, which is not accessible to most non-technical users. So what we've been looking for is what is the middle ground between cloud software with all this real-time convenience and the sort of old-fashioned desktop software which stores files on your own computer. And that compromise, the best of those both worlds, is what we call local first software. So the core idea of local first software is actually really simple. It's the users have some storage locally on their own device. In the case of native apps, they can just write to the file system. In the case of browser-based apps, there's like IndexedDB and so on, and even some new APIs for file system access. So it's possible for cloud software to store data locally on the user's device. There may still be cloud services, absolutely, but at least if you've got the data locally, that's something that is much harder to take away from the users. And so really what local first software is just kind of change of focus, change of priority, that in the traditional cloud software model, really any data that was not stored in the server database basically didn't happen. Any data that's on the client is basically just a cache. It's very ephemeral. Whereas with local first software, what we're trying to do is make the data storage on the client the primary copy. Data storage on servers probably still exists. I mean, you could use a peer-to-peer network, but I suspect that for many practical applications, cloud services will still continue to be used. But we just changed the emphasis that cloud storage is no longer the primary storage. Cloud storage is now just essentially a backup mechanism, and it's a way of syncing data from one device to another. And so this change of emphasis looks like a small thing, but actually it has a very big impact on the way that the software is developed and also on the way the data is controlled by the users. So one example, for example, one thing is that offline work just works absolutely fine with local first software because you're just updating data that's stored locally on your own device. And then sometime later, when you come back online, then there can be a protocol that syncs those changes in the background. And so the user interface doesn't have to wait on whether you're online right now or not. Another advantage is that the programming model becomes vastly simpler. So compared to this traditional web app model where you've got a huge number of layers of application code, what we're saying with local first software is essentially the application code exists only on the client. And so you've still got, if you're in a browser app, you've still got your JavaScript application state. But when you want to persist that application state, you just talk to a local library in your browser and store the data locally on your machine. And then the data synchronization process that takes your data and relays it to the machines of any collaborators who are working on the same document, for example, that is just general purpose library code. You can just use an off-the-shelf implementation of this data synchronization framework. And any servers that are involved in the data synchronization similarly are just generic pieces of fungible infrastructure. So this is in the same way, like if you're writing a server-side application, you will probably just use a database like Postgres or MySQL or something like that. You probably won't write your own database because these open source databases exist that are perfectly fine, and you can just use those for doing your persistence. Likewise, in a local first model, what we're trying to move towards is that this storage and synchronization library that you talk to on the client side, that is just general purpose infrastructure. It's not specific to any one application. It's just a general purpose library that you can use. It's just open source. The protocols by which it talks over the network are hopefully in the fullness of time open standards where there are many different server implementations that speak the same protocol, and the server is not application specific. The server is really just a way of relaying some bytes from one client to another. Another nice thing with this local first model is that it also opens up the option of end-to-end encryption. And so, you know, from apps like Signal and WhatsApp, end-to-end encryption has become very widespread when it comes to messaging. But there's this huge class of other applications like collaborative document editors that are currently generally not end-to-end encrypted, where the cloud provider just has access to the plain text. So what I mean with end-to-end encryption here is that rather than just encrypting data as it goes over the wire, using TLS, for example, the data is encrypted in a way that the server, even the server, just sees the ciphertext and doesn't see the plain text. And now if we're doing all of the application logic on the client anyway, and the server is just a relay for some bytes from one place to another, that now opens up the possibility to have this end-to-end encryption, because the server doesn't need to interpret the contents of the operations anyway. It's just pushing some bytes around. Okay, so here's a comparison between the cloud software model and local first. So in the cloud software, this building real-time features where several people can edit and see each other's updates in real time is actually very hard. And with local first software, we've got the opportunity to build in real-time collaboration from the start. Like, this is just part of the programming model that you can support this. With cloud software, making it work offline is kind of difficult. You know, it is possible, but it just pops out very naturally if you're writing software in a local first style. I talked about already the risk of users losing data if they become locked out of a cloud service. So with local first, users have a copy of the data locally, and for example, they could then just choose to push that existing data to a new synchronization service, and then they continue being able to work and they don't lose any data in the process. And finally, what we're working towards with local first software is that the synchronization service is generic, so it's not tied to any one particular application, but it's just a general purpose piece of infrastructure. Whereas in cloud software, everyone who runs a cloud app needs to write their own server backend, which talks to some databases, which means they then need an on-call team of engineers who can be woken up in the middle of the night if their cloud service goes down, which means it becomes very expensive to actually operate cloud software. And we're hoping that with local first software, more of that synchronization and storage can be outsourced and pushed just to vendors so that the application developers themselves don't have to have these on-call rotations. Now, I don't want to pretend that local first is amazing for everything. I think it really applies to a certain class of applications and not to others. So let me try to pull that apart a bit. So I think local first works very well for what you might call file editing software. It doesn't really matter what the file type is, whether it's text or spreadsheet or slides for a presentation or vector graphics or pixel graphics or video editing, whatever. But with all of these types of software, you've got users creating a file and the user can edit that file in whatever way they like. That's essentially the characteristic of this type of software. And moreover, there's this sort of productivity software class, which is like note-taking, shared to-do lists, issue trackers, calendars, and those types of things, which again, the users can update in whatever way they like. Where local first does not fit well is where there's some sort of real-world resource involved that actually has to be managed centrally. So for example, say it's the balance of a bank account and the transactions on a bank account. Yes, I could have a copy of my current bank account statement on my own device, and I could try updating it locally, but if I update my own local copy of my bank account, the bank does not care. You know, the bank cares whether the money actually came in to the account or not. And my local edits to my bank balance have absolutely no importance from the point of view of the bank. So this is different. I can't just edit my bank account in whatever way I like. Whereas in a text document, I can edit it in whatever way I like. And the same is true of like warehouse inventory, for example, or vehicles or things like that. Whenever there's these kind of real world resources involved, that's actually a place where I feel centralized cloud infrastructure works just fine, and we don't actually need to change that. So what I'm interested in here is just this left-hand column of software where I think local first is a good fit. So very briefly, I thought I might tell you about a particular software implementation of these ideas that we've been working on. So AutoMerge is an open source library that can be used to build local first software. That's what it's designed for. And the data model it provides is essentially JSON. So if you wanted to make a to-do list using AutoMerge, you would represent it perhaps like this. For example, you've got a list of to-do items, and each to-do item has a title, which is like the text that the user has entered, and a Boolean called done, which indicates whether the user has checked the checkbox on whether that item on the to-do list has been done already. You can add further bells and whistles, but this is a sort of basic thing. And now let's say that a user wants to mark an item as done. The way you would do this in AutoMerge is the state of the JSON document is actually an immutable object, and you can call this AutoMerge.change function in order to update any part of this JSON object in whatever way you like. And so here, for example, you would now pass in the current state of the document called before here, and you would get back an updated document in which that change has been made. And in this case, the change that we want to do is done here in this callback, where in this case I take index 1 of the array of to-do items and set its done field to true. I can also associate a textual description of that change with it optionally. Think of this like a commit message in Git, for example. So it's just a description of what the change did, but it's otherwise not interpreted. Also, you might have another user on their device because this data is present on multiple devices, and each user might update that device independently, perhaps while offline. Let's say that another user independently on their device wants to add a new item to this to-do list. And so here they would call todos.push. That's just the JavaScript API for appending a new item to a list. And they would add this new item, do laundry, which has not yet been done. And this then just gets added as a new item in the to-do list. And so this is the basic API on how you can model data changes in AutoMerge. Now, what I said just now is you might have different users on different devices independently updating this data. And so, for example, here we have user A setting water the plants to true, and user B on a different device adding do laundry as a third item to this to-do list. And so AutoMerge now handles the data synchronization so that the updates on one device get relayed to the other device through whatever network is available. And it now also merges these changes together, and it does so automatically. So unlike Git, we try to not expose merge conflicts to the user, except in very narrow cases where we can't do any better. But in this case, we can do an automatic merge quite reasonably using the structure of the JSON document that we have here. And so in this case, the merge that AutoMerge will do is just, well, it preserves the fact that water the plants had its done field set to true, and it preserves the fact that a third item, do laundry, was inserted into the list. And so this way, the different users all end up in the same state. They see the same state of the document. And in that state, we have preserved all users' edits as much as possible. This also applies to text editing. So for example, if you wanted to build a Google Docs clone, or in many other applications, you also get text. If it's a presentation slide deck software, that will typically contain text on every on every slide. And likewise, you could have different users editing a text in different ways. And so here, for example, let's say the red user edits the document hello to add the word world before the exclamation mark, and the blue user on a different device adds a smiley face after the exclamation mark. And the way AutoMerge will now merge these edits together in a way that hopefully reflects what all of the users wanted. In this case, the word world will stay before the exclamation mark, and the smiley face will be after the exclamation mark. Now, we can have a longer argument on whether you think this sort of automatic merging is really the right thing to do. You might think that maybe manual conflict resolution is the right thing to do. That's a sort of longer debate that I didn't really want to get into too much today, because I really wanted to focus on this idea of local first software. But the idea is that a library like AutoMerge can provide this sort of general purpose storage and synchronization mechanism that allows applications then to hopefully build collaboration software in an easier way. The way how this works internally, in case you're interested, AutoMerge is what's called a conflict-free replicated data type, or CRDT, which essentially just means it's a data structure that can be independently updated by multiple nodes, and the changes are merged together in a deterministic way so that everyone ends up in the same state. Moreover, CRDTs have the nice property that they work over any type of network. So you can synchronize your data via a server if you want, but the server is not really involved in the conflict resolution. It just forwards the messages around, which means that if you want to run over a peer-to-peer network, that actually works just fine as well, because we're not depending on a server to perform any particular role in the protocol. And so if you can get your bytes from device A to device B via a peer-to-peer network, then that is perfectly fine with AutoMerge as well. Just briefly, I'll finish with a few words on how AutoMerge is implemented. So this is a library that's written in Rust, and you can use it through a Rust API if you want, but we picked Rust mostly because it's portable to many platforms. And so, for example, we compile it to WebAssembly and then have a JavaScript and TypeScript wrapper library around it, which you can then use to build applications in web browsers. But there's also a C API, which is then wrapped by a Go API if you want to write servers in Go, for example. If you want to write mobile apps in iOS, there's a Swift API. Likewise for Android, there's a Java/Kotlin API, and so on. So the idea here just being that there's a single implementation of the data structures and algorithms and synchronization protocols, and you can build apps on any platform that is built on top of this kind of general purpose layer. Underneath, the AutoMerge itself is really just a data structure library. It doesn't do any I/O. But if you want to save your data persistently to disk, or if you want to send data over the network, well, you need adapters to particular storage and networking libraries. And so for storage, there's AutoMerge Repo, which is a companion library that provides I/O. For storage, we currently have adapters for IndexedDB in a web browser and file system for native applications, but you could plug in whatever storage happens to be available on the platform that you're running on. And then likewise for networking, you could go via WebSocket server, you could go peer-to-peer via WebRTC connection, you could use a plain TCP connection if that's available on the platform, which wouldn't be on the web, but for native apps, of course, you could just use plain TCP. Any sort of way of getting the bytes from A to B is absolutely fine. Yeah, and that's really all I wanted to talk about. So the concept of local first is articulated in this essay, which is the first URL on this slide. The open source implementation of these ideas, AutoMerge, is the second URL. And yeah, I hope we have a few minutes for questions still. Thank you very much.
Thank you, Martin. Okay, are there questions?
Well, one thing I might then just say, like as to the IETF and IRTF audience in particular, is like right now, you know, open source is AutoMerge is just like one project in this space. There are other libraries trying to do similar things, but where we're hoping this will go in the medium to long term is that we will work out a data synchronization protocol that works for a wide variety of applications. And it would then, once we've got that general purpose protocol, it would make sense to try to standardize that in an open way. So that then hopefully, my ideal end state for this is that various cloud providers or various vendors of any sort will provide interoperable hosting services for local first software. And so then if you have your local first presentation app, for example, you can then just give it the URL of your syncing service, log into your syncing service, and that will then interoperate with anyone else using that same software. And if you have a separate app, maybe a text editor, you could likewise plug it into the same syncing service and just have a single syncing protocol that applies for a wide range of applications. So maybe that's something to sort of think about in the future as these protocols evolve. It would be really great to keep talking with the IETF community on how it would make sense to standardize those kinds of protocols.
Yeah, great, thanks. I mean, we are happy to discuss this further. So in the meantime, we have people lining up for questions. So Dino, I think you were first.
This is Dino. Regarding your example with world and smiley face being merged, do you use a global timestamp or is it first message arrival? Why did you put the world before the smiley face versus the opposite way?
That's because when the original edits happened, the red user inserted the world before the exclamation mark, and the blue user inserted the smiley face after the exclamation mark. And so in this case, the order is unambiguous because the exclamation mark acts as a separator, essentially. So it wouldn't make sense to suddenly put the word world after the exclamation mark, for example. Now, if two users insert text at exactly the same position in the document, in that case, the resolution is essentially arbitrary. So it's based on a logical timestamp in the events. We then pick which order to put them in, so that everyone ends up in the same state.
So you support global ordering?
What do you mean exactly with global ordering?
If it was multi-participant, you would know when the source inserted before it arrived at, since there's no central point, it's source-based with local timestamps, you said. True?
Yes, exactly. So there's no server, there's no consensus protocol in here. It's just looking at the timestamps in the messages, essentially, to determine in which order they should be placed.
Okay, Rio.
Hi, Rio Yanagida from University of Glasgow. So I think the idea of the local first application is something I think is a very good idea, and I think it's nice that sort of it's put in a sort of definition of some sort. But then I struggle to sort of see what's the sort of the leap from, say, traditional sort of application that have a server-side component, so local first, but has a server-side component, was quite common. I mean, say, for example, Adobe Creative Cloud stuff, all of that stuff mainly works on local, all the files are local, and you have a cloud component, right, that helps you synchronize and collaborate. Is this the model that you're going with? What's the departure from that, from the existing model?
Yes, so the Adobe software is actually fairly close to the local first model already. It doesn't have the kind of open protocols, open and generic servers aspect that we're trying to aim for, but it does have the local data storage. This is very different from Google Docs, for example, where there's no local data storage, really. I mean, yes, you can just about enable offline editing if you install an extra browser extension, and then it's still incredibly fragile. So I think the Adobe apps here are the exception rather than the norm, and we're trying to move a greater set of software in that direction.
Okay, thank you.
Okay, and one more question, Raul.
Hi, Rahul Gupta. Just a comment. I was just downstairs at Dispatch, and there is a proposal for a state synchronization working group / research group. So you might be interested in that. Just wanted to point that out.
Awesome. Yeah, if you could like share a link to that or something like that, I would
Sure, I would
love to hear about that.
Thank you.
Well, sorry, I jumped the queue. If you talk about state synchronization, I'd also like to contact you that we have done a number of works in that area.
Yes, love to talk about it further.
Okay, I see no further questions. Then thank you very much again, Martin, for bringing your work to us. It's super interesting, and hope to talk to you again soon. Thank you. Bye-bye.
Great. Thanks for inviting me.
All right. And last but not least, we have Mark McFadden, and I'll bring up the slides.
Thanks. When you're sitting in the front, you don't actually see that there are people having to stand in the back. That's amazing. Okay, this is a contribution to the conversation we've been having about consolidation. This is sort of a reflection on some of the work that other people have done and taking a look at sort of the broader work that is available on consolidation. There's lots and lots of excellent work here. There's, of course, the IAB workshop that took place in 2019. There's also an ISOC white paper that dates from around the same time, although it focuses pretty strictly on economic issues. There's a full issue of the peer-reviewed journal, Cyber Policy Journal, in 2020 that was devoted to consolidation. There's a lot of work here. And of course, there's the Nottingham draft, which is in, I think, the RFC editor's queue at the moment. There's a lot of academic work as well. And so one of my interests is to actually read this work and understand what's going on. And one of the things that I found was that given that there's this very broad set of work going on here, that there's some interesting characteristics, and that's going to be my contribution here with this draft. Now, one of the things in a previous DINRG meeting we got asked was, well, is there a definition of what consolidation is? And in fact, not only is there a definition, but you can celebrate a little diversity because there are many definitions, right? But they all take on sort of a similar property. And here There are three. There's one from Jari Arko's draft, which is now expired. There's one from the Nottingham draft, which is moving towards RFC. And then there from the ISOC paper, there's also a definition. And I won't read these, but you can see that in general, the tenor of each one of these definitions is pretty similar. And I think there's a case to be made that yes, you could come up with a definition of what consolidation is. And so I think that that objection, which has been raised in the past, no longer applies. But one of the things that I reflected on in doing some reading in this space was that a lot of people are talking about consolidation, but they're talking about different things. And so that's why I'm proposing a taxonomy here. And I was thinking about this very slide, and I was thinking about Jeff getting up at the microphone in an early presentation and saying, hey, it's economics, stupid. That's not what he said, but that's what he meant. And so I'm going to, what I want to talk about is that other people talk about consolidation and come to it with a different point of view. Consolidation is real, but people talk about it in different ways. And your perspective often is determined by the kind of stakeholder you are and what your role is in the network. Are you purely a consumer? Are you a provider? Are you a network engineer, or so forth? In terms of a taxonomy and how it would affect the IETF, a lot of people have talked about the relationship between consolidation and protocol development. And I'll have some words to say about that later. I certainly have some strong opinions about that. This is intended to be a piece of research supporting the research group into the kinds of large groups of consolidation work that people are doing in the community. And I think when this research group recharted, this is the perfect place to do this work. My draft, the draft that we're talking about here, breaks consolidation into four big categories. The first one is economic consolidation, and I can tell you that that's the dominant area that people talk about. And so that when you're actually going through a bibliography and looking at all of the people who are talking about consolidation, this is the one in which you see the most work being done. I'm also going to talk about traffic and infrastructure consolidation. This is, if you read Jeff Houston's blog, this is something that he's talked about in the past as well. I'm also going to suggest that there's another category that isn't talked about as often, and that's architectural consolidation. And I'll describe that in a moment. And then finally, something that we're well aware of is service and application at the top of the stack, at the application layer, service and application consolidation. Let me say a few words about each of these categories and why I think it's important to have the categories in order to have a rational conversation about consolidation. Economic consolidation, as I said, is the dominant theme of work in consolidation. The ISOC white paper is notable because it emphasized economic consolidation. It talks a lot, and by the way, that's a long piece of work. That's more than 50 pages to get through. And here's a quote: a handful of actors play a significant role in our increasingly connected society. In this context, it's important to consider what the implications of those trends are. But the implications that the ISOC paper looks at are primarily economic ones, right? And what those economic trends mean in terms of consumer choice, in terms of network diversity, in terms of security, and so forth. Other authors argue repeatedly that that economies of scale are the reason that we see consolidation. That's a really common theme. We see that in paper after paper, especially academic papers. And the economic reality here is the source of some gloom in certain quarters. I won't accuse Jeff of this directly, but Jeff's not the only one who has, and forgive me for characterizing it this way, over a period of time, measured in years, come to the conclusion that not much can be done. Right, that's sort of the conclusion, and Jeff's not alone. The Nottingham draft has changed over time. It was originally somewhat optimistic. It's no longer, if you look at version 13 of it, it's no longer very optimistic. But I also believe that it's important to know that there's a group of people who come to consolidation and talk about traffic and infrastructure consolidation. that what we're seeing is traffic flows on the internet are actually dominated by the networks of a small group of people, a small group of organizations, right? So what we're seeing here, for instance, and an example that was given to me by one vendor is that if someone creates a cat video in Hong Kong and someone wants to see it in South Africa, that very cat video may never traverse any other network than the network the video was actually created on. It's incredible to me. And so the globalization of those networks has meant that traffic is consolidated into individual vendors' networks. In certain markets, access itself, so consumer access to the network, is dominated by a small group of players. So what we're seeing here is infrastructure actually controlled by a very, very small number of players. And so as consumers we have very few options, but also ISPs have a few options as well. And my last bullet here is that in the mobile space, what we've seen, especially in developing markets, is that the dominant incumbent players have come to dominate access as well. And so once again, consolidation has taken place primarily for historic reasons. I'd like to convince you that there's another group of consolidation, another category of consolidation called architectural consolidation. We had someone had a slide in a previous presentation today that sort of talked about the fiction of the end-to-end principle. I'm old enough to know that the end-to-end principle actually used to be true. So that makes me, what, 70 years old. But the end-to-end principle no longer applies. That's just not the way we do the network anymore. And it's not built that way. It's not the way that we make it affordable. And now what we're doing in protocol design here at the IETF is we're actually putting intermediaries in place, right? Over and over again, we have protocols like Privacy Pass, OHI, and there's a whole bunch of them, where we're starting as an IETF to design protocols that deliberately have intermediaries in the path, in the network path. And some protocols, Privacy Pass is an example of this, actually demand that the number of intermediaries in the middle of the path be small. Okay? It's actually built into the protocol, baked in. So an older argument was, I heard this many times, even from people on the IAB, is that consolidation is not an issue for the IETF. But if we're designing protocols that have consolidation built into them, it surely is a topic for the IETF, and certainly for a research group. And lots of people talk about this other category, service and application consolidation. What we see are one-stop shops. We see application layer tools that are extremely effective and are built in such a way so that if you use that tool, you're part of the ecosystem that uses a set of tools and you have a sort of one-stop shop. I have some statistics here. These statistics are kind of old. They're from 2021. But some examples of particular vendors who provide those one-stop shops. Now, the size of those dominant companies and the companies like them is due to network effects, that if users like those tools, more users will come along and take advantage of them. The tools become better, more users, and so on and so forth, right? You have that network effect in place. Now, the goal of this draft is really to help us organize our thinking. That's the idea, is that there's not just one kind of consolidation here, that there's actually 4 big categories of consolidation. And I've tried to lay them out in a way so that it makes sense for further conversations here in the research group and in other places as well. And providing a framework to think about consolidation has sort of been my goal. Now, what I'm looking for here from the group is comments on whether or not the taxonomy as it stands, these 4 items, are granular enough. Okay, does it make sense in terms of organizing our thinking? Are there things missing here? Now, primarily where these 4 categories came from is reading the literature that has arisen around consolidation on the internet. And the question that always comes with a draft like this, are there things that would be useful to add to the draft? And with that, Dirk.
Thank you very much.
I'm on time.
Yeah. Very well. Thanks a lot. and we do have questions. So Nick in the queue. Thanks.
Thanks.
Hey, Nick Merrill, UC Berkeley. Thank you so much for that talk. That was great. I have a lot to talk about, probably more than can fit in this question, so we'll leave that for offline. There's one thing as far as what was missing. I did some work with the Internet Society and also at UC Berkeley about centralization, not just of the companies that manage this infrastructure, but the legal jurisdiction in which those companies operate. So we did a bit of research on that, and however few infrastructural operators there are even fewer countries in which the jurisdiction for in which their jurisdiction is. I'll give you one guess as to which that country is. Unless you're Canadian, it's the country we're both from. So I wonder how that fits into the taxonomy, if at all, and if not, why it should be excluded. And then the second bit here, and I'm curious to hear what you think about either or both of these, is, there's this apparent paradox that I find myself discussing or defending a lot when I talk to people about this. On one hand, the internet's physical infrastructure has never been more decentralized. If you want a copy of a web page, it's in 100,000 different places at every, eyeball facing ISP. On the other hand, its management has never been more centralized. There are only 3 companies that manage those points of presence at those ISPs. And I feel that theme is somehow lurking in this taxonomy, but I'm curious to hear your thoughts about whether it should be more explicit or whether it's adequately captured, or how you think that tension arises.
Well, so for the first one, which was jurisdiction, I'm glad you brought that up. There actually is, besides the work you've done, there are other academic pieces of work that have been done that talk about consolidation of jurisdiction in, and it's an important issue because it informs some regions' approach towards regulation. For instance, the European Union as an example. So I think jurisdiction should be a part of a future draft. Maybe not a category, but a discussion of jurisdiction. The tension that exists between decentralized devices. When you think about the Internet of Things, for instance, right? And you think, boy, there are lots of devices all over the place that are providing data, but also consuming resources, right? And you say, well, that's a very diverse community of devices out that are out in the network, right? Much more diverse than, say, 15 years ago. But I'm not sure there's a place for that conversation in this taxonomy. That would be an interesting piece of research on a separate plane, I think. But for me, your first comment about jurisdiction really rings true for me, and I'll think really carefully about that.
Okay.
Oh my God, there are 5 people in the queue. What have I done?
That's me? Okay. So following up on that, I think actually I'm doing a self-advertisement. This research group ran a workshop back in 2021, and we published eventually the workshop report early this year. And that actually touched upon the issues people just mentioned. The pointer to that workshop report is on the DINRG wiki that Dirk showed you earlier. Go there, can find it, read it if you have not.
It's also in the references in my draft.
Yeah, okay. Yeah, that's a point there too. So, but from originally I raised my question just to clarify one specific point with regarding to end-to-end principle. I think today it's not just we lost the end-to-end principle, we lost the end-to-end. When I communicating with you, the end is not you, the end is the cloud. That's where we are. The end-to-end get fractured. We no longer have direct end-to-end user communication. It's all like going to the cloud, and then the cloud will come down to the other end. So this is not just the principle is broken, the infrastructure no longer supported.
Ignacio.
Hello, thank you for the presentation. 2 disclaimers, 1 question and 1 comment. 1 disclaimer, I have a background in economics, so I'm biased on that sense. I have not read the draft, just the presentation, so everything I'm saying is based on that. As you were talking about this taxonomy, to me, with my economics background, it all sounded to me like that's economics. That's economic consolidation at the architecture level. That's economic consolidation at the application level. So first, I wonder whether that would make more sense and whether maybe it would make sense to talk with some economists that have better and more solid background on the topic than myself. And the other question is that, as Geoff was saying before, economies of scale are powerful gravitational forces. Standing on their way is frequently not a very good idea because you are very likely to be crushed. And even if you don't, you might make the system more inefficient as a whole. However, there are ways to reduce the problems that they entail. And for example, if you think about interoperability, that has been one of the ways in which monopolies in application at the application level are being contested. And similar thing with, for example, internet access providers, making the contracts less sticky is one of the ways in which even with a relatively small number of providers, you can increase competition because it's not only the number of players, it's how easy it is for the people to switch among them. Those are two different things to be taken into account.
Well, thanks, Ignacio. First of all, I'm not an economist, nor do I play one on TV. And so my background is pretty much network engineering. And the fact that I think, especially in the academic literature, people take these four categories and very, very often wrap them around a economic narrative, that the economic narrative is what's driving these four kinds of consolidation. What I see in the conversation, in the dialogue in the community, is that these four strands, these four sort of contexts are very different, and people talk about them in different ways. And so that's why I'm bringing the taxonomy to the table, is that when I read the literature, I see a lot of conversations about consolidation. And as I said when I was introducing this, the economic part of it dominates the conversation, absolutely does. But also the application layer consolidation also is a very interesting and much discussed part of consolidation. So I'll take it under advisement to reconsider the economic part of this and maybe think about how it could either be extended or made as a wrapper for the narrative for the whole thing. Thanks for that.
Okay, Jeff.
Uh-oh. Now I've gone and done it.
Sorry, Jeff Houston. Look, I was actually reading a book called The Chip Wars a couple of months ago, and it kind of surprised me that when you look hard at the underlying industry in which we work, it's all grinding to a halt because of physics. When we're down at 3 nanometer chips, we actually have no idea how to make it smaller unless you get into 3D masking, and we can't do that cheaply anymore. And in fact, the cost per gate is now rising, not falling. What that means is that the previous 30 years, where any business plan in our community did not survive more than 5 years because of Moore's law, by the time things got 32 times cheaper, 32 times faster, that whole doubling process inexorably disrupted and ground out the old incumbents, and it brought in agile money. Mm-hmm. And the reason why the American companies dominate our world, oddly enough, is indeed economics, but it's because in America, it's okay to go broke and go bust and go bang and do it all over again. Whereas in Europe, it's a crime. You know, trading while insolvent's frowned upon in this part of the world. Whereas in America, it's kind of, oh yeah, it'll work again soon. You know, so what actually happened was that technology impetus countered some aspects of consolidation and bred other parts of it. That's coming to a close as we speak. Because next year's chips are this year's chips. Next year's Mac is just this year's Mac colored black. There's no change in the fundamental economics of the technology base. I can't wait for 3 years and get much more humongous software that'll work at the same cost base as today. No. And I lay our stuff up, it's going to get more expensive. So now when we get back into being a more conventional business, where technology is no longer a constant, dramatic, disruptive force, does that mean that the existing incumbents right now are much, much harder to unseat? That when the music stops, then the ones that are there are the ones that are there, and there's nothing you can do. And the real argument in the chip sort of world is, has the music just stopped this year? Is it over? And I would actually like you to think about that when you think about some of these themes of consolidation, because I believe that the final missing theme is actually the underlying theme of our technology lifetime so far. Moore's law has been prodigious, but it ain't going to do it anymore. We've reached physics limits. And at that point, the entire landscape changes in a bad way. In a bad way, because the ones that are there, and no one else can be.
Yeah, so to the rest of the group, did I mention that some people have a darker view of this? But I agree with one of your fundamental observations, and that is the end of Moore's law, right? That's fundamentally coming up, as you say, against the laws of physics, and smarter people than me are well aware of that. The end of Moore's law and the effect that it has on networking is something I'm really interested in, but I haven't done a lot of work on, right? I think that that's something that needs to be exposed to the larger community. It's not, for instance, talked a lot about in academic papers. I can't find it anyway. And so I think that would be a great future contribution, either here or in other places, to start to talk about, well, what does that mean that we can't keep counting on technological improvements to drive innovation, right? What does that mean from an economic point of view? But I also think from a network operations point of view as well, right? That I'm not going to have better and better routers. I'm going to be stuck with the ones I've got, right?
Well, you pay more for better ones. But my point was, what are the implications of that shift for consolidation?
Right.
Right. And I think that's actually one of the biggest themes out there, because when Moore's law grinds to a halt, everybody's got a problem.
Right.
Right. And I think that's going to be a dramatic theme over the next couple of years.
I'll talk to you offline as
Sure.
well, but that's something that would be useful to actually have in this draft.
Wonderful.
Thanks.
4 more minutes, 3 more people in the queue.
Hi, Rahul Gupta. Very interesting talk. I'd like to talk a lot more offline also.
Okay.
Right now, just maybe one issue I'd like to bring up. Where do you see the role in your taxonomy data decentralization fitting? So for example, I use and also contribute to a project called Solid, where we are trying to store individuals' data separately, even if they are being accessed by a centralized application. So how would you, where would you that fit in your picture?
So I think that would be a reaction to the second of my categories here, and that's the traffic and infrastructure category. That one of the things that this draft doesn't have is people's responses to these four kinds of consolidation, right? And I think what you're suggesting there is an example of a response to that kind, an attempted response to that kind of consolidation. That might be something helpful to add to the draft in the future.
Thank you.
Thanks.
Hi, Mark. This is Carolina. Great to see you. I guess I wanted to bring in a brief comment and perspective from the Internet Governance Forum that I just participated in, just to welcome, I think, the work on this taxonomy for decentralization or centralization, I should say. So the IGF has been struggling with defining what internet fragmentation means for different stakeholders, and they just finalized this process through a policy network, I think they call it, where they put out a taxonomy, if you will, for internet fragmentation. I think that's been very useful in terms of organizing the conversations. I welcome your efforts for a taxonomy for centralization at IETF. Reacting to your ask for feedback, you know, to me, in the context of IETF, it makes sense to think of centralization across layers of the internet stack. So the sort of economic aspect of it felt sort of off place at first, but then I think it's somewhat of the invisible hand that drives the whole thing. So I think it makes sense to have it. I second Nick's comment about jurisdiction. I think that's an interesting one. And I wanted to borrow a category of the internet fragmentation taxonomy and offer it to you. And that's fragmentation from the perspective of the end user. So maybe also thinking about centralization from the perspective of the end user. what are people sort of, missing out on? What does centralization mean for people that are unconnected? Perhaps it's not an element of the taxonomy, but it merits conversation or discussion within the draft.
Well, I know I'll get a chance to talk to you offline about that as well, but I do think I have a separate draft that is titled "The Effects of Consolidation," but I've come to the conclusion that Mark Nottingham's draft is far superior, and I'm just not going to continue with it. But and shall I say darker? But the idea of talking about what consolidation means from the end user perspective is actually worth following up on. I think that would have a place in the taxonomy. Thanks.
Hi, Vittorio Bertola from Open Exchange. And by the way, given the previous comment, I'm the guy that has been trying to write the definition of internet fragmentation in the paper that was mentioned. So, but I noted one thing. I mean, it's nice to have a taxonomy of the consolidation, but apart from the economy of scale is one of the main causes, there's a lot of technical tricks that are employed by these companies to promote their consolidation and basically close down the market and make sure their users, their customers don't go anywhere else. So I'm wondering whether we also need a taxonomy of that, a taxonomy of things like closing down interoperability, preventing portability, because these terms are often used and used in different ways too. So maybe we need to do some work on that as well.
Yeah, maybe. I think that goes in a different direction than I was intended with this taxonomy, but I think that's worth thinking about, that it's not just effects and it's not just a discussion of the kinds of consolidation, but also the kinds of techniques that are used by companies to enforce that consolidation. Thanks, Vittorio.
Okay, great. Thank you very much, Mark, again. That's really great. Thanks, everybody, for the great discussion and great questions. We really should give Mark additional feedback on the mailing list. So there were many good points raised, but just let's not waste this chance to move this work forward. This concludes our meeting. Thank you very much for attending. This was super interesting, super lively discussion. Hope to see you again soon. Thanks. Bye-bye.
I was taking notes on this, but I missed a couple of the questions on the first presentation. So if you had questions on the first presentation, you can take a look at the notes and/or something. Yeah.